Yeah, dear students, application 19 చూడండి. I am taking the two blocks having the masses m comma m and charges q1 comma q2 separated by distance d. Because of that, there is a repulsive force between the two charges when they are at rest. So that force is nothing but Fe. So Fe means 1 by 4 pi epsilon naught q1 q2 by r square, or k q1 q2 by r square, or d square. Here distance between the charges is d. That electric force which is equal to tension. Why? Because in between the two blocks there is a existing a force called a tension. So because of string, so the tension is equal to electrostatic force. So T equal to k q1 q2 by d square. For maximum value of tension, there are two equal charges will be there. So to find out the equal charge value on the two blocks, so we can write T maximum equal to k q square by d square. Q1 equal to q2 means you will get k q square by d square. From that q equal to, take d square into left side, so t d square by k, so square coming to right side root, so 2 root of t maximum d square by k. So k is nothing but 1 by 4 pi epsilon naught. So you can substitute the value, you will get charge value root of 4 pi epsilon naught t maximum d square. So this is the one of the application to find out the tension in terms of charges. Okay, now between the two blocks they will mention the charges, they will give the in the problem the blocks having the charges q1 comma q2, and they ask to find out tension between the two charges or two blocks they will ask. So in that case you need to equate at equilibrium condition. At equilibrium condition, tension is equal to electric force. So you can apply the formula, you will get the answer. For maximum value of tension they will mention means you can find out the charge. Coming to application number 20, find the charge q if tension is maximum. They asked to find out the value of charge when the tension is maximum. They took the two charges 2q and q separated by distance d, and between the two blocks we have the tension force T. Tension force is the pulling force, and the repulsive force between the two similar charges Fe in the towards left. So Fe equal to capital T maximum. Here this value will be the T maximum. They mentioned maximum value of tension between the two charges. So T maximum equal to, between the two charges, what is the force formula? 1 by 4 pi epsilon naught 2q into q, 2q square by d square, which is equal to Fe. From this they asked to find out charge value. So find out the q square value by taking all these values into left side. You will get 4 pi epsilon naught d square t maximum by 2. Square coming to right side root, so root of 4 pi epsilon naught d square t maximum by 2 is the formula for to find out charge. They will give the maximum value of tension, they will give the distance between the charges. We already know 1 by 4 pi epsilon naught value 9 into 10 power 9. By substituting those values you will get the charge on the blocks. This is application number 20. Coming to application number 21, a fixed charged body at the bottom of inclined plane and another similar charged body at top. Find their charges if they are at rest. Consider the plane is a smooth inclined plane. Smooth inclined plane is nothing but we are neglecting the frictional force on that plane. So by taking the two charges, one charge at bottom, one charge at top of the inclined plane, between the two charges there is a distance d. Between the two charges, distance between the charges is d. And here for the topmost charge, what we have the block, that block having the mass m. So that mass m having the weight mg acting vertically downwards. Here in the inclined plane concept, the friction chapter, loss of motion chapter, you will get one concept. The weight can be resolved into two components in the case of inclined plane. Nothing but along the theta is called mg cos theta, perpendicular to theta is nothing but mg sin theta. If you observe the diagram, what we can equate is nothing but mg sin theta is balancing with electric force Fe. Why? Because mg sin theta downwards, exact opposite you are getting electric force Fe. So at equilibrium condition Fe equal to mg sin theta. We already know Fe formula 1 by 4 pi epsilon naught q into q, nothing but q square by distance between the charges d square, equal to mg sin theta. From this I want to find out charge. So q equal to root of mg sin theta into 4 pi epsilon naught d square. So square coming to right side, root will come. So a mainly thing you need to remember here, we need to equate mg sin theta component with electric force at equilibrium condition in the case of smooth inclined plane. Coming to application number 22, a fixed charged body at bottom of rough inclined plane. They mentioned rough. Rough means we need to consider the frictional force also. Then we need to find out the charge and what is the equilibrium forces we need to equate. So for this I took the inclined plane having the theta angle. Between the bottom I am considering the charge q, mass m, and the topmost block is q having the mass m, between the two charges distance is d. So again this block in the topmost we need to resolve into two components, weight mg downwards, mg cos theta along the theta, mg sin theta along the plane of the inclined plane. So in this case at equilibrium condition, so here what we can understand is nothing but the motion, the frictional force is always opposite to the motion of the body. So because of this here, so if the block is moving downwards means the friction force upwards. So that's why in the direction of electrostatic force only frictional force will be there. At equilibrium condition, this mg sin theta component is equal to Fe plus F. How we got Fe here? Q, similar charges repulse each other. There is a repulsion between the two similar charges because of that electric force away from the charge. So Fe and frictional force also opposite to the motion of the body. So Fe plus F, which is equal to mg sin theta. Small f means frictional force, Fe means electrostatic force. So coming to, we know that frictional force formula in the case of friction chapter, small f equal to mu mg cos theta. Why? Because small f is proportional to m, small f equal to mu n. Here n is nothing but mg cos theta. Normal reaction which is equal to mg cos theta. Finally we got formula for frictional force mu mg cos theta. So Fe equal to, take this plus f into right side, finally you got mg sin theta minus mu mg cos theta. We already know electric force between the two charges 1 by 4 pi epsilon naught q square by distance between the charges. I am taking here r, so you will get r square will be the distance between the charges. So finally you got mg into sin theta minus mu cos theta. Here I want to find out the charge formula by taking 4 pi epsilon r square into right side and take the square into right side, you will get root. So root of 4 pi epsilon naught r square mg into sin theta minus mu cos theta. This is the charge formula for the rough inclined plane. Very important applications.